Okay, so let's start where we left off last time. So, what did we do last time? Last time we did some couple of fixes all around the Effect cluster. We did some quick fixes, some little changes, but today I want to tackle something quite big, and that something is basically move everything from Effect platform to Effect RPC. So what do I mean with that? I mean that right now we have a system. Let me show you the system that we have right now. Okay, so this is the system that we have right now. Right now, the system works by having different processes. This is, for example, the shard manager. The shard manager is basically the coordinator for all the servers that keep track of your application server that are running. This one is the shard manager. And as I start new processes that are able to host your entities that are called pods, they register themselves to the shard manager, and then any process can message to any entity without knowing in which server is actually running, because this is basically called location transparency. You refer to an entity based on its entity ID instead of actually knowing where he lives over your server. And this is really nice. This also allows your application to scale because, for example, here now I can start a new process, a new entity manager, and this process, this pod, which is now an entity manager, will register itself to the shard manager, and now the shard manager have seen that there is a new pod that is able to run entities, and so what will happen is that slowly but surely entities will be assigned from the old server, will be even out and moved to the new server, and they will balance themselves. Okay, so we have a shard manager, which is basically a process that coordinates everything. And now the process that can run entities can be started. They will register themselves to the shard manager. And then entities, as you can see, will be started to be balanced between the two processes that are able to balance the entities. And now you can see, for example, that entity 0, 2, 3, 4, 2, 4, 6 will run these processes, and entity 1, 6, 1 is running on these other processes. So basically you can scale up as you want, as you wish, your system. So imagine, like, for example, some system that will spawn up new server when it sees that you're running short or resources are running too high on each process, and spawn up new different services, and each server will basically be the same, but they balance out the load on all the server, and you can set up maybe some threshold that when the server is not doing enough work, it can shut itself down, like I will do now. And what will happen is that now the pod will see that the server is not responding anymore. What will happen is that now the shard manager will assign back the entities to the old server that was running, which is the only one that is running up right now, and slowly everything will start again. And also there is settings that allows you to control how many entities you want to move from one server to another slowly. Let's say 50% of the entities that are living on a server, I want to move that 50% of the entities each 5 minutes or something like that, and that is in order to avoid that the network shape of the communication between your entities changes every second, because you can imagine having a situation where servers are going up and down really fast due to some issues, and not having that settings basically will let you in trouble because your network shape will change continuously, which is not ideal. So basically it's trying to keep the entity working. What I also want to say is that the shared manager is only a coordinator. So let's say that maybe now I start back the old pod that I had before. Okay, now I started back. And now you can see that now he registered back himself into the network. Now it has, and again, entities to process. And what you will see is that even if I shut down the shard manager, everything keeps working. Because right now, as long as the network shape doesn't change too much, all the pods have a local cache of all the pods that are alive and where entities are living. So even if your shard manager dies for a moment or takes some time to restart, you can have your system working. Federico says, I always thought that infrascaling should be coupled to upcode because it can know how and when it should scale. I see something integrated with Pulumi. And Mike exactly says, ideally this can also instruct KHS, exactly. Basically, you can have your shared manager or your app code tell the infrastructure how many entities running, if maybe it is going to struggle or something. You can do that either on the infrastructure side, so having the infrastructure manage and control the percentage of the usage of the resources that your pod have, or the opposite side, having the pod tell the infrastructure, okay, I'm struggling, maybe start something new because I need more resources. Okay, so after this quick demo, maybe we can start doing something. Okay, let's shut down everything. Okay. Okay, first thing, I want to update Effect everywhere because there were some patches. So I want to update Effect everywhere. So Effect in files.json. Okay. So right now I am on 306, which is not the latest one, which is 311. Okay, so quick and dirty update. 306 becomes 311. Okay, and then we update the dependency accordingly. The latest one is 6613. Okay, we set 13. Okay, and then we have also other dependencies to update. Let's have a look at cluster node, which is one of the packages that has most dependencies. Okay, we have Effect platform, which now is 52.1. Here we go. And platform node should be something like 48. Yeah, 48.2. There should be some more intelligent way to do whatever I am doing manually right now, but to be honest, I don't care too much because it's something that I usually don't do very much. So I'm fine with some search and replace. Okay, schema should be 6613. We already updated that. Okay, Effect is updated. I think that the only thing that we are missing that is we have Effect RPC, this sample app, which now should be something like 32, right? 30.16, okay, only patches, no minors. 16, right? Right. Okay, now quick npm install. Well, oh, platform node. Did we miss to update that? I think, yeah. Packages, JSON, platform node, right? Let's see. Package, platform node. 44 requires platform, okay. 52.1 found 0 docs, okay. Is in cluster PG, okay. Let me have a look here. What are you saying? Platform node, okay. Oh, I see. Platform node requires platform, yeah. Yep. That's fine by me. Let's try again. And right, yeah, we also have SQL in here. SQL PG now is .16, 1.16. Okay, and we should have SQL only in here, so we're fine. Okay. Okay, now we do what we do always, npm check. Let's see that we don't have broke nothing. Okay, nothing is broken. Maybe we clean and we build again. And okay, that seemed to be fine. And maybe some docgen. Shouldn't be nothing new. Okay, succeeded. And here we are. Okay. And then some test. And if it passes, we are golden. Let me have a quick sip of water while it builds. Oh, also, I forgot my effect cap. Okay. Now this should take some time because we are waiting for Docker to run the test containers, but ideally shouldn't take too much. And after that, I think what we can create the PR. Yeah, I timed out, but yeah, I'm fine with that. Okay, git checkout -p upgrade effect, and we are now on effect 311. Okay, upgrade effect, and that's it. Effect. Okay, now I was finally able to type it right. Publish. Can you use test clock? The test fails on CI and 16 is a bit long for a test. Yeah. It's not actually the test clock problem. The problem is that that test relies on spinning up a test container Postgres, and that always took ages, at least in my setup with test containers. and it goes on timeout because of that, because it takes too much to spin up the test container Postgres. Oh yeah, I should indeed look into not running that always. Yeah, it's something that I need to speak with Phoebe, which is more experienced with me with testing setup and dev setup, in order to make so that that test, the Postgres repo test, only works. Yeah, I used to work at a layer before. Yeah. Another thing I thought is that maybe I can use only a single test container and then just create a different database for each test, and that's it. Maybe that's something better. And now instead of creating, let me go to the, instead of creating a test container for each test, which is what I'm doing right now, I am basically creating here. Yeah, yeah, I should do that in before. Yeah, if I make that part of the, yeah, and in the before all, I should start the Postgres container, shut it down in after all, and in each test I just can provide a different database name. Yeah, I need to maybe add that to the issue. I need to fix issue. Oh, I need to sign in. Okay, so upgrade effect. And I need to add to the issue. Okay. Do not recreate test container for each test. Instead, use before all and after all, and then use a different database for each test. Okay. It should be as an arrangement. Okay. Okay, so let's see our pull request. It's now merging. Merge. That's it. Okay, so now we successfully updated effect. Let's go back to main and pull the changes. Okay. So why are you? Oh yeah, I need to restart my server. So we figure out that we have updated effect. Okay, and now everything is fine. Okay, so now we can start having a look at Effect RPC and see how we can use it in our project. So let's start by having a look at the examples. RPC HTTP is the one I want to implement. Okay, so we have a schema, router, a client. Let's start by having a schema. So Effect RPC or PC, and we should then have our RPC request either extend a class or a tagged request. Okay. So either a tagged request from schema, which is what I think I will use, because at the moment the protocol does not have any stream request. It all relies on request response without having something that is streamed from the server to the client. So let's go back and say right now, let's go to here, cluster node. Let's start by adding the dependency. Now, not on Effect platform, but on Effect RPC. both on peer and on dev dependencies, and run a pnpm install, pnpm install. That's it. Okay. So back in the days, I had something really similar on how Effect RPC works, because I had those two protocol files, which is the sharding protocol HTTP and the shard manager protocol HTTP, which back in the days relied on returning a schema, ping shards, yeah, struct, yeah, a schema. Those are all the requests. Yeah, and each request, if I remember correctly, returns something like an either, right? Let me have a look back. Like the protocol, register, notify an healthy pod, or get a send result, okay? And now the actual HTTP calls a register, yeah, and just responds true, okay, and the client uses the register, yeah, okay. Schema body, yeah, this is the register, okay. Yeah, I think that most of these things will effectively die thanks to Effect RPC, yeah. Okay, so let's try maybe starting by the sharding protocol. Okay, so we have the assign shard method, which now should become something like export class assign shard, extends schema dot tagged request, identifier should be something like assign shard, and now we have to provide a tag, which will use something like affect cluster node, and then sharding protocol HTTP, maybe just sharding protocol since we are dropping the HTTP, and then assign shard. That's very long, but to be honest, I like it. And then we need to provide the failure schema. So are there any failure? No, they aren't. So schema.never. And are there some response? I think no. So it just schema.void. Okay. And that's it. So, oh, you're missing the self type, yeah? Assign shard, yeah? Do I remember correctly? Oh no, the other one. I always forget the order of the parameters. Let's see, schema, tag request, myself. Oh, yeah. Okay, schema.tag request here. And now, oh, I'm missing the fields, yeah. Those are the fields on my request. Okay. And it is fields after the success type. Okay, so it's the error, the success, and then the fields. Okay. And the fields that we have is shards, which is basically schema.set. Now we have it. Hash set. Okay, we didn't have it back in the days. Now we have of shard ID that comes from shard ID dot schema, and that's it. And then we have unassigned shards, and I think that I will just copy this one and maybe change the name. Unassigned shards. Assigned shard. I will also make it plural since it's actually unassigning shards, not only one shard. So it's better. Shards, and here, okay, unassigned shards here, here, and goes the same, okay. And then we have send, export class send, extends schema dot tagged request, not class, tagged request here, and send, and takes in the same no identifier but the same tag, which is this one. Okay, but it's send. Okay, it never fails, but takes in a message which is basically a serialized envelope dot scheme. Okay, and that's it. Oh, this is send result. Yeah. So we actually have a failure for our send, and that's right, yeah, because it can fail because maybe the entity is not registered or something happened, and we have as a response we have a message state. Yeah, so now those ones are actually only one type instead of two different schemas, and I really like that. And then we have the last one, which is ping shards, and I will rename this to ping shard instead of shards. Start request ping shard. Okay, and I don't expect this to fail, so never. And I want to return nothing and has no parameters. This request is used by any pod or the shard manager to ping a pod and effectively know if it's up and running or if it died. If the pod responds, everything is fine. If the pod doesn't respond, okay, he died. So we have now the schema for the protocol, which is basically the union of all the possible requests. But since we are using now Effect RPC, instead of having a schema, we now have a router. Okay, so the router needs to be exported from the part that is handling the server, so cannot be exposed anymore from here. So let's just kill that. Okay, I also want to rename this as sharding protocol instead of, and no, I don't want to update imports. Okay, and now I want to have sharding service RPC instead of HTTP, and this will import sharding protocol. And now we need to import everything as RPC from Effect RPC, RPC, RPC. And we also need the router, I think. Yes, we also need router. As router from RPC router, and that's it. Okay. So this will change a little. So const router equals, and let's use the same style of, so RPC router.make, and then we handle different kind of requests. So router.make, and now here we handle the different kind of requests. So rpc.effect, and the schema is sharding protocol, not HTTP anymore, so need to rename this. I have my mouse that needs to be changed. Yeah, I need to change mouse. This one, okay, is dying. Sharding protocol, okay. Let's start by assign shards, okay. And we have the request, and the handler will be basically something like calling sharding.assign, and then we pass the hash set. So will basically be something like pipe sharding dot sharding flatmap sharding dot assign. What are you complaining about? Oh, pipe. I need to import pipe. Yep. And now you should be able to assign request dot shards, and that's it. Have a look. Man, it's so clean. This is using Effect platform HTTP, and this one instead is using the Effect RPC. Man, it's so clean. And maybe now I can handle the unassign shards. We'll call unassign, and now there are, oh look, the router is fully typed. Yeah. If you make sharding.tag and effect.tag, it becomes a single line. Oh, yeah, I'm still have this one in the old style, but yeah, that even becomes a single line. Yeah, you're right. Because you get for free that fancy thing of, yeah. Ooh. Okay, so let's start maybe by, yeah, the proxies. Yeah, that fancy thing. Now you tempted me. Now you tempted me. Now I want to move to that thing. Yeah. Let me just implement those methods and see that everything is running, and then as next tasks I will move to that to clean up something. So assign, and then we have rpc.effect sharding protocol. Isn't it frowned upon to use frown? I don't know what frowned means. Sharding protocol. Ping shard. And oh, by the way, welcome. Effect.succeed. True. Oh, not advised to. Yeah. I don't actually know, but if Mike says so, I would say that you are perfectly fine by using it. What is this from that? If you use effect.flatmap and blah, you are already accessing it and using it at the same time. So while it's from up, yeah, it's in general case, yeah. Now, what are the missing requests that I am missing an assigned ping. Oh, send message. Yeah. rpc.effect, and we have sharding protocol send and has a request. Yeah, it's more advice. Yeah, for user apps. Yeah, I would say that. Yeah, maybe library code. Yeah. Sharding protocol to send, and now send is send used to do a lot of things because I basically had some kind of RPC that I built myself before, but now I can do something that is, I can do the same thing, pipe sharding dot tag, and then effect dot fatmap sharding, and then this one and this one, and then request dot message, and that's it. We have our routers. Look how is clean the typings, that it says all the kind of messages that is able to manage and the environment, the context that it requires. And all of these can basically die and not be a thing. I need to export this, I think, export const router, and says that since 1.0.0, and I need to say also category. I would say router, RPC maybe. Okay, so this is my RPC, and now I also need to export the type of the RPC. So export type sharding service RPC equals type of router, and this is the actual router typing, because the client will just rely on the type and not on the actual instance of the router. Oops. And now main client, and now what we need to do is maybe change the sharding. This was the protocol. Okay, this was the service that is exposing the service. Now we can kill all of those dependencies. Okay, okay, and the internal server is not needed anymore. I can kill relying on these, relying on these. Well, look how it's clean now. Okay, and this is the sharding service. And now we have the shard manager, client HTTP, and also the pods HTTP. Okay, so now the pods HTTP should be renamed to something like pods RPC, because now the pods communication relies on Effect RPC, not on HTTP anymore. And we need to import sharding protocol, that can be renamed into sharding protocol. Rename symbol, sharding protocol. That's it. And now, let me see, is HTTP URL. Now this relies on the actual client. of the RPC. So I'm curious if the resolver comes from the RPC and HTTP resolver. Yeah, the thing is that resolver to client. Yeah, I would like to have this not rely on the actual HTTP, actually relying just on the platform or the Effect RPC, but I need to take a quick look on the Effect.website typings to see. Let me have a look at the API reference and go to Effect RPC. Okay, we have the resolver. We can even use resolver no stream, to be honest. But yeah, let me look at the resolver to client. And the resolver to client takes a resolver and makes a client. Okay. Okay, resolver.make, and this takes something. A resolver to client. Okay, and now then you can use the client to ask RPC. So let me say that maybe I can request the user to provide a client and then call that to perform the requests. Yeah, definitely. Yeah, definitely. I remember that it was relying also on being able to, if I remember correctly, to just type client. Yeah, it's actually using a request resolver. Yeah. So ideally, I should be able just to yield the request. So if I do something like, let's say, let's try something like const test equals pipe, and we just say new sharding protocol dot ping shard. Okay, and now this should be an effect. Yeah, I need to yield this in new. Let's say maybe effect.gen, and then function star const a equals yield star new sharding protocol dot ping shard. I thought that you can, those were requests, so you can, oh, affect dot request. Yeah, and you need to provide the data source. Okay, okay, now I see. Oh, hi there, Millet. How's it going? So we're in the middle of refactoring Effect cluster from using platform HTTP server and client to using Effect RPC. And we are having a look at the API for our client. And let's start maybe by adding as a dependency, maybe Effect RPC HTTP, so we can try it out. And running a npm install. So we install the dependency. And let's start by doing the exact same thing that the example does. So it uses both resolver and HTTP resolver. Okay. And then it constructs the client. I need to import from import type, because I just need the type from Effect cluster. or maybe just reference the file directly from the sharding service RTTP sharding service RPC. So this is an HTTP resolver of sharding service servicer. Okay, and this now builds a function that, given a request, is able to produce an RPC.result of that. Okay, and this is basically a resolver.client. Okay, resolver.client is something that takes an error that is a result. Okay, or effect request resolver. Okay, and then takes resolver and builds a client. Okay, and then just fine. And then the client is something that takes a request, okay, and builds an RPC result. Okay, so I think that in the end I want to basically export just the client, but yeah. Okay, let's start maybe with that. Okay, so when we call the assign shard, now what we want to do is effectively call just client.
You know I don't play right. I'll put up a good fight. Just give me the word.
This is now the client. Oops.
I feel like you know I don't play right.
Not sure why I copy pasted it twice, but yeah, I'm fine with that. So client. Okay, now everything is on error and is on fire because here now we need to replace everything with just return client and new sharding protocol dot, and this is assign shards. Assign shards and the shards, and that's it. Yes, that's basically it. The thing is that, now that I think about it, is that we need to be able to build dynamically a client for each pod address, because a single pod is able to communicate with different pods, and each pod has its hosting API. Yeah. So what do we do? Maybe we do something, let's start simpler, but do something like function. We need something that function make that takes in a build client, and this build client takes a pod address, which is a pod address dot pod address, and given the pod address creates an RPC dot client or RPC dot client, right? Did I import that? I didn't import that. Import everything as RPC from effect RPC. Okay. RPC dot client. What is exposed the client type? Oh, it's not in here, it's in the resolver. Okay, so we already have resolver. So resolver dot client. Okay, and it takes an effect of request resolver. Okay, so a client, and maybe we should pass in the sharding service RPC, right? No, it's not what you're looking for. What are you looking for? Let's see. Client. I want to be able to understand. I need to listen to be. This is a client. The client is basically something that takes a request and builds an RPC result for that request. So maybe I could use that. In the end, I want something that builds a client. Yeah, but I'm not sure what this client is expecting. Let's say go to definition client, stands request resolver, or an effect that produces a request resolver of an RPC request. Okay. And what I want instead is not that. I want something that I see that in here it's able to produce what I want, because what I want is actually this RPC result, and this should be an alias for an effect if I remember correctly. Yeah, it's an effect, a stream, or yeah, an effect. So this is what I'm looking for. But I'm struggling finding it should be tied. Yeah, extends effect request resolver. Oh, I see. It takes a resolver. Yeah. Oh, hi there, Mirella. How's it going? Very nice cap. Yeah, indeed. So I need to figure out how to build a resolver without relying on the specific RPC HTTP. So let's see, resolver RPC resolver. Yeah, it's defining here. So maybe.
Catch myself thinking about where you
Request resolver. Maybe we can do that a little bit differently, saying something like that, and saying that I will able to provide you a request resolver that takes in those requests. Yeah. Let's try it like this. Okay, I import everything as request resolver from effect request resolver. Okay, and the client of request resolver that is able to address requests of type sharding service RPC dot request by using an environment of type R or sharding dot sharding. Yeah, let's try something like that. So right now it's not happy because this is not a thing. Sharding server HTTP. This is a router. So maybe we already have the instrumentation to do something like rpc.router. Let me try something. This one in here. Let's try with rpc dot request
times that
of sharding service RPC. No, this is not my one. I wanted something like to be able from the router to extract the types, but yeah, I think that is exposed from, yeah, I need to export type sharding service RPC request equals router dot request of type of router. Yep, type of router. Yes. And now this should be all the individual requests. Perfect. Perfect, perfect, perfect. Models. And now that we have the type of the single requests that can be handled, maybe we can do something like sharding service. Where's my cursor right now? Yeah. Sharding service RPC dot sharding service RPC. Oh, everything as sharding service RPC dot request. Request resolver of this. Following order, yeah. Okay. What are you concerned about? Request resolver of China does not satisfy that because request of any is not following that. Let me try to break this down a step at a time. Let's say that I just want to make something that, let's try just make it static and say I want this. Okay, I just want to build and be able to extract this and say type A equals this. Are you okay with that? For sure you don't know about R and you also don't know about sharding. Yep, that's true. Import everything as sharding from effect cluster sharding. Are you happy now? Yeah. And now this is a request resolver. So now can you build a client out of that? No. Because request resolver or request never. Oh, never. It doesn't need any environment. Oh, I see. I see. The client requires no environment. Okay, I see. Yeah. Yeah, because, yeah, okay. So never. This should work, right? Does not constrain a request resolver of a request or effect request. Okay, request resolver is not assigned. Request is not assigned. Why are you telling me this? Request resolver, okay. Request resolver require an environment and is capable to, okay, and this is okay. But resolver.client, this is saying that I can either extend a request resolver that takes any RPC request. RPC request, oh, RPC request. And I'm not using RPC request, but I am using the schema right now, yeah? Okay. So let's see if the RPC request is just an alias for, oh, request is something, oh, request of, and then you have your tag scheme. Okay. Stands left. Okay, yeah. So let's see if maybe in all the types exposed by router we have something that will help us. We have context, contextual request, response, response effect. Okay. Yeah, I think I'll try to just use. Are you typing the client manually? Can't you derive it? Yeah, I can derive it from the router. But the thing is that maybe I'm not figuring out correctly the APIs for Effect RPC. What I would like to is that I want this spots RPC module to do not rely on the specific kind of RPC, like for example RPC HTTP. And this is just the example that I copied from the examples that we have right now. Just me. Okay. And the thing is that I need to first make a resolver, and the resolver unfortunately is in the actual module that relies on the HTTP. I didn't look, maybe there is a make. Oh, there is a make in here. There is a make in here, yeah. Just write a type like router request and then you can derive. Yeah, I already have that one. And this is this one, which is router. Okay. What I'm struggling is finding out how can I have the client type for this. Okay, so this is the router and I need the typing for the client. So basically the function that takes in the request and runs the effect, which I found where it is. That is basically the, not this one. Yeah, this one. Client. I want this. I want this to be built. Maybe I can go to references and see where it's references. Found the references. But yeah, it seems to be referenced only in here. I want this type that takes the request and builds the RPC. But yeah, is the request resolver. I expected R to be the single request type, but instead is the request resolver, and I am struggling building the request resolver. I expected something like type B equals resolver dot client of, and I expected here to put my, let's say for example, sharding service RPC dot. I fail to understand why you need to do that too. Because the thing is that requirement that I would like to have is have this RPC module to do not rely on the specific RPC implementation, being HTTP or whatever RPC protocol will be provided and supported in the future. And in order to be able to have the pod communicate with whatever pod it wants, I need to have a type signature that provides you basically a function that, given the pod address, constructs the RPC client that is able to communicate with that pod. Okay, so that needs to be dynamic. I cannot just have a static RPC client. I need to have something that is able to build RPC client given the pod address. So this is basically the function that I'm trying to build. I'm trying to build something that, given a function that has the pod address, constructs a client. So basically, I want this to be request dot, and here I have my sharding server RPC request, and this returns effect dot effect of request dot success of my request. To be honest, should be something like extends this. Okay. And then if I import everything as request from effect request. Okay. I want to build a type signature that works like this. Okay. So this is independent of which kind of protocol you are using, because basically you are just instrumenting your code to saying that given I know the pod address, I can give you a function that when called with a specific request that can be one of the protocol, I am able to run it inside an effect with no environment requirement. Or maybe I can have that, but I would like to provide that on top. And I was trying to look at the RPC typings to see if I can use something from the typings that allows me to do that without manually type that. Yeah, I will indeed try to chat with Tim about that. For now, I think that I will use this, because the thing is that I fail to understand how the current APIs, given you are required to first call the actual resolver implementation, and after that you can provide the global resolver to it to client. I am failing to understand how this allows you to build something that is agnostic of the kind of protocol you have behind. Yeah, but for now I will basically use this type signature. Maybe I will not have any requirement on the environment. Yeah, it doesn't. Yeah, it doesn't, but in my opinion, it should provide some kind of this API, right? And okay, so effectively we are looking for something like this. Yeah. Okay, so let's say that we have the build client that builds a client to the specific pod address. Okay. And then we need to build our specific functions. Yeah, assuming the protocol is abstracted, exactly. So let's say we start copying. I hate this mouse. I need to change that. I don't think even the server is like that at the moment. The server seems to be able to do that at the moment, because I was able to write the entire server router implement. At least I can expose the router without knowing which is the, yeah, here for example I created successfully the router without knowing which is the protocol given HTTP or whatever you would have, and that works, and at least at type level. And the thing that I am feeling too is the client. Yeah. Okay. So let's maybe write this one, assign shard. Okay, now you can see that now I want to do something like, yeah, I know the pod address, I know the request that I have. So this is effectively build client. Okay, so build client, for the given pod address, then send the request, and this is effectively the actual implementation of the assigned shard that I need to provide to build my layer. And that goes the same for unassigned shards, and then we have ping, that just takes in a pod address, so new, and the request is just ping with no parameters. And then last one is send message, if I remember, send and get state, yeah, which used to do quite a few logic, but now shouldn't, because I can do something like function send and get state of pod address given a pod address dot pod address and message being a serialized envelope dot envelope. Maybe envelope is better naming. Envelope. Okay, and I should already have the explicit typing in here. I didn't. Okay, that's fine. And now I should be able now to return build client for pod address, new sharding protocol, send, and this is the message. Message, envelope. Yeah, message. Let me rename in the protocol instead of message. Let's rename this to envelope. Yeah, that's better naming. And now the typing for these. Yeah, look at this. So clean. Message state, and those are the possible exceptions that could happen. Yeah. Yeah. And ideally, the typing that should be added by RPC should be something like baking RPC dot communication error or something like that. Yeah. If I have a look at the resolver, you should have something like additional errors given RPC.result, and these ones should introduce additional errors. Yeah, because we could imagine having errors over the wire, so I expect that RPC results at least introduces new errors. Oh, it doesn't. So maybe all the communication error are automatically moved into defects, maybe? Because yeah, it's something that we don't expect, but yeah. But yeah, in the end, I expect this to be something, and then return pods.make, and we provide unassigned shards, unassigned shard, ping, send and get state, and now we're happy. Yes. And the only thing that I am curious is that now if we also use the environment R, yeah, this breaks because he expects the environment to be nothing. Yeah. But we can provide it, yeah, because we can make this an effect itself. And like we did here, we can access the environment in here, yeah. Let me just think where should be the best point to do that. Sunshine, Packet data resolver and event memory should be provided on creation. Yeah, the thing that I want to do is basically I want to convert this, what I call the make right now. I want to make this a layer that takes in, so a function that constructs a layer, that function takes in a build client, and the layer may have some environment. Yeah, so maybe I can make this be R, but then I could do something like, I can do something like return layer. Yes, and the resolver. Yes, and the layer, of course, and the resolver constructed inside the layer with a fixed temp. Yeah, and the resolver constructed. Yeah. Effect and is pods dot pods, not pod, dot pods. Okay, and then provide the effect, which is effect dot gen function star. Okay, this, and here I can do something like const env equals yields star effect dot context. So I resolve the context preemptively, and the context will be of type R. Yes. So now I can make this be never. Yes. Now this looks like function and builds in a layer. Yeah, that perfectly. And now I need to provide dot pipe effect dot provide my env, and that's it. Now it should be happy. Yep. So I can have this require some context and just provide that in here. Yes, and now as you can see, typings are happy. And now I can kill whatever I had before. Everything in here dies. That's nice. Look at that. How many dependencies I don't need anymore. Okay, some of those I added. This was an internal implementation. Now I don't. And now export function. Can't we just use the provide? Can't we just use the provide that applies to all the function? I was already using context R. Yeah, yeah. Ideally we can. Yeah. I'm used to this API because yeah. I mean, one provide instead of multiple provides. Yeah, we could. I'm used to this because back in the days when I started Effect, yeah, I just learned the 10 APIs I need. So this is one of the 10 APIs I need, and I did everything else with those 10 APIs. But yeah, that could be a point. One can use that different API. And then we have everything, pods to make. And now if I tell infer function return type, let's see, it builds a pod and requires R. Have a look at what is nice. Okay, so now maybe I rename this as pods RPC. And since 1.0.0 and categories, layers, given a function that resolves, given a function that resolves an RPC client, constructs a pod service that uses RPC to communicate. Okay. And eventually, when I figure out how to use the typings provided from the RPC client, what I can change is that instead of manually typing this function, I can do something like, okay, I'll take in an effect that takes an environment and produces an RPC client that can handle some kind of requests. Yeah. Okay, but this is good enough as a starting point, I think. And now we did the pod part, the client part. And ideally, we should be able to run it, I think. Because right now, the communication between pods will rely on RPC. So we can go to our example and see that run main is complaining because there are some broken typings. And that's it because we have now, instead of pods HTTP, we have pods RPC, maybe with a capital P, and sharding service RPC. Okay, and rename this as well. Pods RPC, sharding service RPC as well. Okay, and now it's not sharding service HTTP because here instead I need to provide the router. So let's see, how do we start? Let's go back to examples and see if how do I build an RPC server. So router, okay. We start with http.router.empty and then we provide thing and launch the layer. Okay. And we still need to rely on platform node indeed, because that is everything. We need RPC, RPC, HTTP. Yeah, basically all of those are required. That's fine. And then let's just copy this live one and rename. Okay, this is instead of router we have our sharding service RPC dot router. Okay, and is exposed at a REST API by default, I think. And then we serve the HTTP middleware with log address and HTTP server create server, and this provides basically the implementation for create server, and create server comes from HTTP. We need to pass that as well. Okay. And then layer, okay. And this builds an http.server, okay, and takes in the port and builds an HTTP live. The HTTP live provides what? Provides merge instead of provide. I need to have this sharding service to provide the Oh, right, that's right. Yeah, just provide this one. Yeah, and then this is the router, and we'll live in here, and that's fine. We also need to provide HTTP live, okay, and then RPC pods RPC, and this now requires client, and the client will be something like, we can maybe do this in line, pod address, and this will do whatever the client does. So let's have a look what does the client does, and is as this. And we need to add some imports, HTTP resolver and resolver. We'll clean up all of this later. Let's just make it work. Okay. Instead of being of a user router, it will be now HTTP live is not found. It was. Oh man. Okay. Yeah, there is something in the formatter that is basically broken. Yeah. The fantastic world of JavaScript tooling. Yeah. Save is basically breaking up everything. Provide correctly. Yeah. Effects, and this is provide. By the way, provide method is usually a sign of the correct layer creation, as the provide part should be collocated with creation. Yeah. Right now I need to rearrange everything. I am in the middle of basically rewriting how the layer works. So yeah. HTTP resolver comes from RPC HTTP. Yeah, but indeed I need to change that. Okay. Okay, it seems like it was able to refactor everything. Okay, so pod address, yeah. Sharding service RPC of this kind. And then client fetch HTTP, make request to client. This now shouldn't work. Yeah, because I was using that, but that is not assignable. So just close your eyes for a moment and let me see what's wrong. Okay, but the rest is, yeah, because I need to change this one. Be something like HTTP. Each pod exposes an HTTP API on pod address dot host on the pod address dot port slash API slash rest for a moment. I need to change my HTTP import because it seems like that I have imported HTTP from the wrong module. HTTP dot. Oh yeah, because this HTTP is the one that is provided by the actual platform. So let me see. No, the client one. Yes, Effect platform HTTP client. Yes. And the other one that I have is the HTTP server, not the client. Yeah, HTTP server. And instead, now I want HTTP to be HTTP client. And now here HTTP client dot client, HTTP client dot client, HTTP client dot request dot prepend. Okay. And now, yeah, it's still not happy about that, but yeah, it should be working, because ideally in here it should take one of the requests and give back that. Okay, so to do ask Tim about better typings. Okay, now all the errors we have. What are we missing? From me is not assignable to time. Oh, okay. Effect server, okay, document to server config never unknown. Okay, we have something that is throwing in unknown into the layer construction. Oh, this any. Yeah. Yeah. This is building unknown. Yeah. I'll just say never for now. And now you're happy. Now you're happy. And now I have some imports to delete. Okay. Now we should be up and running. I also need to do the same exact thing in here. Yeah. Because the shard manager needs to have the same provides. Yeah. For now, I think that I will just copy paste them in there, and then we'll fix it later once it works. And then also this one, RPC pods, manager, and this one, RPC pods. Okay, and now I need to add all the imports. Pods RPC. Pods RPC. Okay. And then I need HTTP server, HTTP client, node HTTP client, RPC, HTTP, all of those, yeah. Okay, and we'll provide those. Some of those maybe HTTP client we already have. Node client we don't actually use. And we also need sharding service RPC. Here goes. Okay, node server HTTP we need. Node server HTTP, node server HTTP. Yeah, I need to fix the code style of the examples, but yeah, not what I am up to right now. The manager. Okay, and now to be honest, I don't need this one. Yeah, because this is just caring about creating. Yeah, never mind. I don't actually need that, because the shard manager just needs to interact with the pods, but the shard manager itself doesn't provide any pod functionality. Okay, so moment of truth. Let's see if pnpm clean, pnpm build. Yeah, it was a pleasure for me as well, Mike. We'll go to it soon as well. Let's try to fix some of the issues, and once it builds, I think that I will close the stream as well and go back next time and see if everything works. So cluster node, the index has some imports that now are missing. Pods RPC, pods RPC and sharding protocol RPC. That's sharding protocol. Yeah. Sharding protocol. Yeah. And sharding service RPC. RPC. Okay, it's building.
Keep holding on.
PNPM check. Whoops. What's the issue? Oh, we also have the connect example, yeah. And this relies on just the pods, so it's the same thing as this one, yeah. Yes. Connect. Instead of HT pods, this one, and it should matter. We need to copy some imports. Pods RPC, pods RPC, save. Okay, sharding service RPC.
Tide is always stronger. Swear is my mind is
And HTTP client, yes. HTTP client. Okay, now, okay, everything is building. PNPM test, but actually it's not tested, so yeah, I'm sure that this will work. Oh. So, let's try again. Let's see if it runs. Okay, so let's see, start by starting in the manager and transport error. Oh, this is okay. Let's start first the shard. I break something. I broke something. Something. I broke something. Yeah. Yeah. Oh, I saw what I broke. Yeah, I saw what I broke. Yeah. The Podser PC, yeah, should, when pinging, should call that and affect catch-all goes and should affect dot fail new, and we should have import everything as sharding exception from effect cluster sharding exception and new sharding exception pod unavailable exception pod address. That's it, because whenever the shard manager or a pod starts, basically it tries to ping the other pods to see if they are alive. And yeah, it failed because they are not started. Yeah, so that's fine. And now the shard manager is loaded, and that's fine. And now let's move to start. Okay, let's start maybe some shard. Okay, it registered itself. It's in. Yeah, registering, pod rebalancing, pod register. Yeah, it seems that it's actually doing something. And let's try maybe starting Yeah, the connect side failed. Entity type not registered. Why are you saying that? I have a shard up and running. Yeah, there should be something not working with. Yeah, failed to rebalance spots. Yeah, that's something not working with. There's something not working with their balancing, but I think that I will leave debugging for another stream, I think. Yeah. Let's see. I think that I have still another 10 minutes. Yeah, another 10 minutes. Okay, so let's see if in 10 minutes we can find out what's happening. Okay, so we expect to prefix everything with HTTP host port API REST, right? But is actually that what we expect? So let's see how sharding config. Okay, defaults. Oh, API REST, not REST API, right? Did I wrote that in the wrong API REST? No, API REST, yeah. API REST and REST API, yeah. API REST. That was the issue, yeah, indeed. So let's kill everything and start again with the manager. Now the manager is loaded. And now we'll start again. Shard, registering pod address. And now we start again with the connect. Same issue. It seems like that it's failing to actually register to the pod. The only part that I didn't touch is the one that seems. Oh, well. Oh, now it calls the shard manager, yeah. Registering pod to shard manager, yeah. Maybe that issue is this one. Let's try again. No, it doesn't seem so. Let's try setting the log level to something like, oh, it's already in the bug. Strange. I expected the HTTP client to log every request, yeah. And the server. Okay, let's try to stop the server again. Okay, this is the manager. Shard manager loaded. Okay, and now we start the sample shard. I expect to see since last starting. Okay, send HTTP response, get assignment, unregister, PFS unregister, get assignments, registering, and this is the new one. Pod registered, and I have my, but now it says failed to rebalance spots. I need to. So it's assign shard, build client, protocol assign shard. Yeah, I need to build client. Yeah. Yeah, I need to debug this one. Assign shards, assign shard. Yeah, we need to debug this one a little more. Yeah. But I think that for today, I am starting to be quite tired. We had almost 2 hours of fun in here. So I would say thank you anyone who joined. And next time I think that we'll go over this error and figure out what it's failing. But yeah, at least now we have something that it's building. And we'll see why it's not running as it should do. We should have indeed some errors in the assigning and unassigning phase because it's failing to rebalance the pods. So thank you again everyone who joined, and for whatever was going to have lunch, have fun, and I will tell you when it's next time, so please follow in order to receive a notification for next program stream, or follow me on Twitter at Mattia Manzati. So thank you everyone again, and have fun. See you next time.